Welcome to class this morning, geometry students, on this Wednesday the 25th. Hope you guys are doing well. Congratulations to coming to the last class of the week in geometry. Hope you enjoy your last day of the week and have a nice 4-day weekend. Get some rest and enjoy yourselves. Let me quickly go over some announcements for you guys. There'll be no test or quiz this week, and we've been announcing that all week, so that should not come as a surprise to you. Everyone turned in Monday's homework, so congratulations there. Everyone turned in Monday's homework, so I appreciate that. You need to turn in last night's homework at this time, so right now, would you please make sure your name is on your homework? And some of you, I believe, turned it in early. I think Jasa and Azu turned in last night's homework already. But either way, please turn in last night's homework at this time. And then, Jake, you must take that quiz by today. Now, there's no exceptions on that. I've given you 3 days. And I've emailed your mom a couple times about that, so please make sure you take your quiz today. I don't want to have to give you a 0 or take points off or whatever, so please get your quiz taken by today. All right? And Mr. Harmon should have that quiz. I've emailed it to him, and so he does have that. All right? And let me go back a page, and there we go. Now, let's go ahead and grab your notebooks and your pens, pencils, your calculators, your books. Let's go ahead and get started right away. I'm going to teach a pretty good lesson today, take a little bit of time. Then I am going to give you homework. Now, guys, I expect you to come to class next Monday with your homework done. Some of you might get it done in class today or most of it done. But what you do not finish, you do need to finish over the weekend, okay? So make sure you do that. We're going to look today at something called proving lines to be parallel. Proving lines to be parallel, that's lesson 3.5. If you'd like to keep track of the date, today's date is the 25th, so write that down. 9/25/13. Let me grab a drink of water quickly. We're going to be looking today at 4 ways to prove that lines are parallel. Before we do that, though, before we get into the main part of the lesson, I want to discuss a term with you first that's very important. I'm not going to make you memorize the definition. However, you will need to understand what this word means. The word is converse. I would go ahead and write that in your notes. Converse. I would definitely write this in your notes. I'm not going to make you memorize this, but you need to know it or understand what it means. A converse statement simply means that we take a conditional statement. Do you remember what a conditional statement is? It's an if-then statement. And what you do to get a converse statement is you swap the hypothesis and the conclusion. So in other words, you make your then part become the if part, and you make your if part become the then part. Okay? For example, if I said to you, if the room is cold, then we're going to turn on the heater. The converse of that would be, if we turn on the heater, then the room is cold. That's all that we're talking about when we say that we write a converse statement. We simply swap the if and the then. Now, this is really important. Sometimes a converse statement is true, and sometimes the converse statement is not true. In other words, you might have a conditional statement that's true, but then when you write its converse, the converse is not true. Now that might sound a little confusing, but if you'll be patient, I'm going to give you some examples in a second in which a converse statement is true, and then an example in which a converse statement is not true. But before I get into that, let's review quickly. I want to first of all talk about the word converse. A converse statement simply means we take a conditional and we swap the if and the then, or the hypothesis and the conclusion. Sometimes a converse statement is true, sometimes it is not true. Let me give some examples. Would you please write this in your notes? If an angle is a right angle, then its measure is 90. If an angle, let me see something here real quick. Okay, hold on one second. If an angle is a right angle, then its measure is 90 degrees. Write that down. Now, if I asked you to write the converse of this, the converse, you would write this part here first. You would say, if Write this down, guys. If an angle measures 90 degrees, then, so do you see what I did, students? I took this part and I put it first. If an angle's measure is 90, then the angle is a right angle, okay? Now I want you to go ahead and write that in your notes, and then go ahead and put the word converse and draw an arrow so that you know that you wrote a converse, okay? Now, is that converse statement true? Well, let's see. Let's go to the original. If an angle is a right angle, then its measure is 90. Well, that's true, sure. Is this a true statement? If an angle measures 90 degrees, then the angle is a right angle. Yes, that's totally true. So the conditional statement was true, and its converse was also true, which is fine. All that I want you to see is how to write a converse and understand sometimes the converse is true, sometimes it's not. Let's try another example. Write this in your notes. If a quadrilateral is a square, then it has 4 congruent sides. Now that's a true statement. If I have a quadrilateral and it's a square, so if I have a square, then it has 4 congruent sides. That's true. But go ahead and write the converse, would you please? If I guess we'll say polygon. If a polygon has 4 congruent sides, if you want to say quadrilateral, that's fine. If a quadrilateral or if a polygon has 4 congruent sides, then it is a square. Now you wrote the converse, and that's a good job, and I want you to be able to do that. I'm going to ask you on upcoming tests and quizzes to write the converse of a statement. So you've done it. If a quadrilateral is a square, then it has 4 congruent sides. If a polygon has 4 congruent sides, then it is a square. That's not a true statement. This converse is not true. It says if you have a polygon that has 4 congruent sides, then it's a square. Oh, really? How about a rhombus that looks like this? I can definitely draw a 4-sided figure in which we'll say all of these are 1 inch. All 4 sides are 1 inch, but that's definitely not a square. Remember, a rhombus is a 4-sided figure or a 4-sided polygon that has 4 congruent sides, but it's not always a square. That is not a square. If I took this thing and turned it for you, like, well, that's not what I wanted to do. Let's see if I can. I don't think there's any way to do this. Nope, it's just going to move that. Well, anyways, I was going to try to turn that for you, but that's a 4-sided object that has 4 congruent sides. It's not a square. So in this case, the converse is not true. So sometimes the converse is true, sometimes it is not. Here are the 4 principles we learned yesterday. All right. Now, what I'm going to do quickly, don't write this down. Please do not write this down. Don't write down anything on this page. Just listen to me. What we're going to do today is we're going to apply the 4 converses of what you learned yesterday. And when we do that, you're going to see something very interesting. Now watch this, okay? I'm going to say the converse of this out loud. First of all, I'm going to read this. If 2 parallel lines are cut by a transversal, then the alternate interior angles are congruent. Now I'm going to say this. If the alternate interior angles formed by a transversal are congruent, then the 2 lines are parallel. That's interesting. Let's try this one. If the alternate exterior angles formed by 2 lines in a transversal are congruent, then the 2 lines are parallel, or then we have 2 parallel lines. Let's look at number 3. If the corresponding angles that are formed by 2 lines in a transversal are congruent, then the 2 lines are parallel. If, number 4, if the consecutive interior angles, or this book calls them same-side interior angles, that are formed by 2 lines in a transversal are supplementary, then the two lines are parallel, or we have two parallel lines. Well, students, all those converses that I just read to you are true, every single one. And guess what? That's where we get today our 4 ways to prove that two lines are parallel. We take the converse of this, we take the converse of this, the converse of this, and the converse of this, and we have the 4 ways to prove that two lines are parallel. Now, in the book, they taught these 4 ways as theorems and postulates and corollaries. I'm not going to do that. I'm going to make it pretty easy for you. I just want you to memorize these 4 ways. So here we go. Are you ready? Write these down. We can now state 100% for sure that lines are parallel if, number 1, alternate interior angles are congruent. So if alternate interior angles are congruent, then we know the two lines are parallel. We can state that two lines are parallel if alternate exterior angles are congruent. So if you have two lines, I should have given you an example, and that's very poor teaching. Hold on one second and watch this. Alternate interior angles are congruent. If I give you two lines and a transversal, and I tell you this angle right here is 120 degrees, and this angle down here is 120 degrees, they're alternate. That's actually alternate exterior, so hold on. If I told you this right here was 70 and this right here was 70, those are alternate interior angles. Notice how they're the same, they're congruent. You can then state without any doubt that these two lines are parallel as soon as you know that you have alternate interior angles that are congruent. Did not mean to do that, and let's go like that. And let's continue on. Now, write down number 2, please. Lines are parallel if alternate exterior angles are congruent. Now, if you want to write these examples down, feel free to. If you don't, then just watch. Alternate exterior angles. Well, I'm going to call this 110 degrees. And I'm going to come down here and call this 110 degrees. When I have two lines cut by a transversal in such a way that their alternate exterior angles are congruent, then I can definitely state without any doubt that these two lines are parallel. So that's the second way to prove that lines are parallel. The third way is when corresponding angles are congruent. So if I have two lines cut by a transversal, and I say this angle right here is 80, and I say this angle right here is 80, excuse me. Notice those are definitely corresponding angles. They're both above the parallel lines, the two lines. They're both to the right of the transversal. These are corresponding angles. So when you have two lines cut by a transversal in such a way that the corresponding angles are congruent, you can definitely state that these two lines right here are congruent. And the fourth way to prove that two lines are, I said congruent, the two lines are parallel. The fourth way to prove that two lines are parallel is when you have consecutive interior angles or same side interior angles that are supplementary. So in other words, if I had this was 125 degrees and this angle right here is 55 degrees, those two angles are consecutive interior angles or same side interior angles. And so because I have that right there, if you add them together, you do get 180. So that means these two angles are supplementary. So anytime your consecutive interior angles are supplementary, you can then state without any doubt that these two lines are parallel. And that's all I want you to learn today. I want you to learn 4 ways to prove that two lines are parallel. Now, I'd like you to go ahead and write this in your notes. Please copy this problem in your notes. And I want to ask you, can you state for sure that line L and line M are parallel? Well, let's see. This angle here is below this line. This angle here is below this line, and they're both to the right of the transversal. We call those types of angles corresponding angles. Okay? We learned today in principle number 3, if corresponding angles are congruent when two lines are cut by a transversal, you can definitely state the two lines are parallel. So yes, I know for sure that L is parallel to M. And how do I know that? Corresponding angles are congruent. Always tell why. Explain yourself, okay? All right, how about this one? All that they gave me here was just 60 degrees, nothing else. Well, no, students, there's no way I can state for sure that this line here is parallel to this line here. I don't know that for sure. All I know is one angle. Now, do understand, as I do our usual quick turn right here, do understand that if I had a 60 down here, then I have alternate exterior angles, congruent, and then I could state that these two lines are parallel. But I do not have that, so I do not have enough information. So no, we're going to call these lines L and M again. No, I do not know for sure that L is parallel to M. It might be, but I just don't know for sure. Okay, how about this one here? This is going to be interesting. Let's think about this. Now, the first thing, go ahead and copy this in your notes while I'm talking to you. Now, the first thing I want to point out to you students is this. We don't have a name for these two angles. I mean, if the 80 was here, then I could say they're corresponding angles. Or if I said the 80 was over here, then they would be alternate exterior angles. But we don't have a name. We do not have a name for a top angle here and a bottom angle here. But here's what I can do. Do you see how I have a straight line right here? Sure you do. And you see how this line is coming off of it? Remember, anytime you have a straight line with a line coming off of it, this angle here with one dot and this angle with two dots, they're always going to add up to 180 degrees. They're always going to be supplementary. So that's what I have right here. So I know for sure that if this angle here is 80, then this angle right here has to be 100, because 100 plus 80 gives me 180 degrees. And I know these two angles right here have to add up to 180. Now, if I know this is 100, now I'm going somewhere. Look, this angle here and this angle here, they're both congruent. And you know what we call those two angles? They're both above the two lines being intersected, and they're both to the left of the transversal. We call those corresponding angles. And so we're going to call it L and M again. Yes, I can definitely state that L is parallel to M because corresponding angles are congruent. Corresponding angles are congruent. Definitely. All right. Now, I know that's a pretty short video. I understand that. And I hope you get most of your homework done in class today. If you do, enjoy your weekend. But you know what? I'm really, trying to teach this stuff well, and I really want you guys to get this, but you're just going to have to work hard, okay? And you're going to have to do the homework and practice. That's so, so important. I mean, I could take another 20 minutes and go over this and really be boring, but there's no need. All you need to know is 4 ways to prove that two lines are parallel. Alternate interior angles are congruent, alternate exterior angles are congruent, corresponding angles are congruent, consecutive interior angles or same side interior angles are supplementary. If you know all of that, then that's what I need you to know when it comes to proving lines are parallel. Now, what I want you to do is go ahead and get your books out and start working on your homework. Page 140, numbers 6 through 21, 24 through 29, 31. Please feel free to get help from the video, which is downloaded for you, Geometry 3.5 homework. But I don't mind you watching it to help you as long as you're learning and not just copying. You've got to be ready for the test and quizzes on your own, okay? That's really, really, really important. All right, students, I hope you have a great weekend. I hope you've listened well today, taken good notes, and now work on your homework really well and do a good job with this. Jake, you might want to take a quiz and do this homework over the weekend. That's totally up to you. But if you choose to do your homework right now, don't forget to take your quiz later on today.